Today we will study in detail about SI units and how to convert it from one to another. So we'll start with fundamental SI units. I have already told you that fundamental SI units are those which cannot be derived. It already exists. So first one is the fundamental SI unit for length, that is meter. So first is meter, denoted by M. Now, this is the SI unit. Whenever we do the calculation, first of all you change any sort of length. Suppose it is centimeter, kilometer, nanometer. All these are units of distance. There has to be converted into meter. So how do we convert that? So if it is kilometer, okay, if it is kilometer, then it is equals to 10 to the power 3 meter. Okay, or we can simply assume that 1 kilometer is equals to 1000 meter. Now another one is centimeter. In centimeter, it is 10 to the power minus 3 meter. Okay, this is centimeter. Oh sorry, minus 2 meter. Then comes millimeter. Millimeter is 10 to the power minus 3 meter. So all these are required for conversion. Again, if you go into a smaller level, then comes nanometer. Nanometer is, we write small n, which is 10 to the power minus 9 meter. Then comes angstrom. Angstrom is the unit where we use for wavelength and wavelength, because it is a very small unit for length. For a very small length, we use angstrom. So it is denoted by A and a small dot on top of that A. Like this denotes angstrom. So this is equal to 10 to the power minus 10 meter. There are different other units for calculating distance. For example, for astronomical distance. Okay, for astronomical distance, one is astronomical unit. Get as first one will be astronomical unit, AU. It is one astronomical unit is the average distance of sun from the earth. That is AU, that is astronomical unit. So 1 AU is equals to 1.5 into 10 to the power 11 meter. This is astronomical unit. So instead of writing this big value, we can directly write 1 AU. Another unit for distance is light year. Light year is the unit for distance. It's quite confusing, but light is not a unit for speed or any other thing. It is a unit for distance. So 1 light year is the distance traveled by light in 1 year. So 1 light year is equals to 10 to the power 16 meter. This will be the distance of light traveled in 1 year. Now for mass, this is for all the units are for length. For mass, similarly we have units like kilogram, that is the SI unit. Okay, so if you get any other unit, you have to convert that into unit of mass. So it will be metric ton, that is 10 to the power 3 kg. Another one is quintal. Quintal is 10 to the power 2 kg. Another is gram for smaller units of mass. It is 10 to the power minus 3 kg. 1 milligram will be 10 to the power minus 6 kg. And also the unit of mass for, or what we call as atomic mass. 1 atomic mass, how do we calculate that is, 1 atomic mass is the 1/12th mass. 1/12th mass of the carbon. This will be your 1 atomic mass unit, or the mass of a single atom is taken from the 1/12th mass of the mass of carbon. Carbon 12 isotope, not any other particular carbon. Carbon 12 isotope. Similarly, we have distance for seconds. Seconds, we have millisecond, microsecond, nanosecond, picosecond. So all these things we have to remember how to convert from one to another. This is the basic thing of physics. Without this, it will be very difficult for you to do further calculation in other chapters as well. Because these are the basic things to convert from one unit to another unit. Another is radian. Radian is used for, I already have told you that it is used for angle, measuring angle. So for 2D angle we have unit radian, for 3D angle we have unit steradian. And similarly, we will also discuss about the units such as unit of current, luminosity, and all those things that we will discuss when we study a particular chapter. Okay. So for now, all these basic units you need to remember. And there is conversion, which you have one table in your book where the conversion is given. Okay, with the power. And the meaning of those terms are also given. So we will discuss about that. In that table, first of all, you will get power of 10. Okay, this is one row, and other one is name of prefix and its symbol. These three things are given. This is very important to remember. Now, first of all is for negative powers. Okay, we will discuss for negative powers. 10 to the power 1 or minus 1. This can also be written as minus 1 means 0.1. So, in place of this, we will write it like this. Okay, this is deci. Okay, suppose it is length, that will be decimeter. Okay, decimeter if it's for length. Suppose it's for mass, it will be decigram. Okay, that way we convert it from one unit to another unit. So unit symbol for this will be small letter d. Similarly, for 10 to the power minus 2 is centimeter, centigram. This way the unit can be converted. This is denoted by small c. Third one is 10 to the power minus 3. This will be your millimeter as well, small n. Then comes 10 to the power minus 6. This will be your micro, and it is denoted by a symbol mu. Then comes 10 to the power minus 9 is nano. Very small number, the 10 to the power minus 9, nanometer, nanosecond. This is how we convert, and denoted by small n. Then comes pico. Pico is for 10 to the power minus 12, denoted by small p. Then comes femti. Femtimeter, femtiseconds, all these things are unit. We convert from one to another. Femti means 10 to the power minus 15. Yeah, multiply. Whenever we convert, what we do is we multiply with this given values to convert it from one to another unit to this particular units. This is for negative powers. Now for positive powers, I just tell you, this is already there in the book. You can refer it to your book itself. For 10 to the power 1 or 10, it is deca, denoted by D, dA. Okay. 10 to the power 2 is hecto, 3 is kilo, 10 to the power 6 is mega, 10 to the power 9 is giga, 10 to the power 12 is tera, 10 to the power 13 is peta. Okay, similarly, you need to remember all this, how to convert from one to another. Sometimes we don't need all these things, but sometimes when you study your wavelength, all these things, and the conversion is required, these values have to be remembered. And if you don't know, then just remember the prefix. Or the prefix itself, you will have an idea from how to convert from one to another. So this is about your SI units or fundamental SI units. Now I will discuss about derived SI units. Okay, derived units. Second one is derived units. Now there are units which doesn't have their own original units, so we have to derive from another one. One is first example I will give you, that is volume. Volume doesn't have a unit of its own, so we have to derive from another unit. So volume, the formula of volume is L into B into H. Length, breadth, height is volume. So the unit of length is meter. SI unit is meter. Breadth is also a length. It's meter. Height is also length only, so it is meter. So this becomes meter cube. So from here, volume, the unit of volume is meter cube. Another one is, second example I will give you, that is density. We don't have a specific unit for density, so we have to derive again. Density is mass divided by volume. It is mass divided by volume. Unit of mass is kg. You already know that because it has got SI unit, that is kg. Volume is meter cube. So unit of density becomes kg per meter cube. So such units which has been derived from the basic units are known as derived units. Okay, there are many more examples in the book. Please do refer that. Now, today we will also discuss about another topic, that is errors. I'm only discussing the topics which are important from this chapter. Okay, all the topics which are there are not important for the examination, but these topics, conversion, the basic things, errors, these are the basic things, and how to calculate them. These are important. So I'll directly discuss from this topic. We'll talk to errors in measurement. So we will discuss errors in measurement. So errors, when we do calculation, when we do practical, okay, we are talking about practical. When we do practical, there can be errors. The error can be of any type, or the error can come from anything. You can do error, even the machine can do error. Error can be also done while doing the calculation. So all this thing is the errors, and which is also a very important term, because without perfect calculation is never there. Perfect answer or perfect value we never get in physics. There is always some sort of errors, and to calculate that error we have got different formulas. Okay, we have got different formulas and different techniques. Now the definition of error is uncertainty of measurement. Okay, uncertainty of measurement is technically called an error. So always the calculation cannot be sorted or perfect. So it is somewhat different from whatever the original value is. So that is error. And error can always be expressed, or it has always been expressed in percentage. Okay, so error has to be expressed in terms of percentage. Not another unit is there, so we have to discuss it in percentage. Now, for example, when we calculate density, okay, I have already given the formula. Density is equals to mass divided by volume. Now suppose if the calculation of mass is wrong or the volume is wrong, then the density will automatically be somewhat different than whatever the actual value of density is. So that is an error. So now error is of two types. Okay, first is systematic error. First is systematic error. In the systematic error, first one will be instrumental error. Okay. Instrumental error. Now, instrumental error, from the name itself, we can tell that instrumental means error in the device itself. Sometimes the device doesn't give the actual value which is there, which has to be given. So that is the error or the instrumental error. Second one is error due to imperfection. So imperfection means if it is not perfect, then it will be imperfection. So it will be error due to imperfection. Imperfection of calculation, imperfection of the device or the setup gives an error. Third one will be gross error. Okay. Third one is gross error. Now gross error means error done while calculating. Okay, when we do the calculation, if there is an error, then that will be your gross error. This is one type of error. Now another one is random error. Random error is something which we don't know from where the error is happening in the calculation or while doing the practical. For example, when we do the practical of current, we set up a circuit. Okay, we set up the meter bit circuit or Ohm's law circuit. Then what happens while taking, when we start taking the readings? When we take the first reading, then we stop for a while. We take the second reading. In meanwhile, we start doing calculations. The setup is still on. The current is still flowing, and with the flow of the current, what happens? The heat will be generated. So that heat, the generation of heat, is unwanted. So that is an error. With that heat, what is given is a wrong value can be given. So that becomes an error. So that is random error. So now to minimize the error, we have to try not to give maximum error or not to do maximum mistakes. Or error is itself a mistake while doing practical. So what we do is, when we do the practical, what we do is we take readings of different values. So we take many readings and we bring the mean, or we calculate, or we do the mean of that. So that way we minimize the error. So we'll do the numerical also to understand it's better. Okay, now next, with this is the errors in measurements. Next, what are we going to study is methods of minimizing or calculating error. Methods of calculating error. So there are different methods. So there are different formulas for error and different terms for error. Okay. So I'll give you the formulas. Please note it down. It's there in the book, but please note it down in your notebook as well. First one is absolute error. Absolute error is a difference between the original value and the value which we have calculated. Suppose there is a battery. The voltage of the battery is, or EMF which is provided by the battery is, suppose 1.5 volts. Okay, that is the original voltage which is written in the battery, which is what the company sells by writing 1.5 volts. Suppose it is the voltage of the battery. But when we do the experiment and when we find the EMF comes out to be somewhat near 1.47. Okay, this is the original value. This is the true value. In fact, this is the value which you have calculated. So the difference between that. So how do we find the difference? We subtract this. So by subtracting, we find the difference, and that will be your absolute error. Okay. I hope this example is clear. So for the formula, it is difference between true value and measured value. True value is the value which is originally there. Measured is what we calculate. So it is difference between true value and measured value. So suppose if your true value is greater than your measured value. In this example which I have given you just now, the true value was greater. It was 1.5. The value which I have calculated was somewhat around 1.47. So true value is greater. The formula will be absolute error is denoted by del A is equals to A minus A measured. So this A represents true value. This is the measured value. Okay, it is true minus measured. If your true is greater than measured value. Suppose if your true is smaller than your measured value, then this will just be the opposite. It will be A measured minus A, that is the true value. Okay, this is an important formula. Please note it down. Okay, now the second type of error is mean absolute error. The first one was absolute error. This is the mean of absolute error. So we can understand that way. It is a mean of absolute error. So mean of absolute error is denoted by, this was your absolute error. Mean is denoted by a bar. So mean of absolute error is mean of first error plus mean of second error plus mean of n number of errors, absolute error divided by the number of observation. Okay, this is how you find mean. I hope you have done mathematics also. This is how you find mean. You add all the numbers and divide it by the number of observation. But this value has to be positive. Because this will be clear when we do the calculation itself. For now, understand that absolute error, or this error which you have done before, absolute error is always positive, because we are always subtracting this by a greater number. Okay, greater number minus smaller number, so it will always become positive. So this value has also to be positive. This is the formula for mean absolute error. Now the third one is relative error. Third one is relative error. Now the relative error, or also known as fractional error. Relative error, or also known as fractional error. So this is a ratio, okay? It is a ratio. So this is equal to your mean error divided by true value. Okay, this is the ratio, that is of mean error divided by true value. Or it can also be written as mean error is this divided by true value is A. Okay, now this another formula for error or calculating error is D. That is the last one, which is percentage error. So percentage error is to convert this value into percentage. So how do we convert that? Multiply it by 100. So this will be fractional error into 100. So this is how we convert a fractional error into percentage. Now, ultimately, when we write the error and its range, okay, error and its range, up to what range the error is there. So we write like this. Okay, when we write the error, we write it this way. That is A, that is the true error, plus minus, okay, plus minus mean error, okay, mean error. This is how we write at the end. This A is the true value. This is the mean or mean absolute. Mean absolute error. Okay, this is how we write the answer ultimately. So I have written this. I have explained you the error, different types of error. I will do a numerical for you to understand this better. For that, you can refer to your book. There is a section of questions. After a short answer, long answer, there is numerical questions. In my book, there is question number 13, but you just check the question, you cross-check the question. The number might be different, but the similar question is also there in the book. Okay, so the question is, I will not write the question, I will read out the question. Please just check in your book itself. The question is, in successive experiment measurements, the refractive index of glass turned out to be, okay, there is an experiment done to find the refractive index of a glass. So there are different sets of numbers which they have calculated. The numbers are 1.54, 1.45, 1.53, 1.56, 1.44, 1.54. So to find the refractive index, these numbers they are found out by doing the experiment. There are 6 observations. So now in this question, what do you have to find? First one is, you have to find the mean of refractive index. Now sometimes in the question, your true value is not given. Similarly in this question also, the true value, that is A, is not given. So how are you going to find the A? The mean of all this number, directly when we find the mean of all this number is the A, or your true value is also the, in this question, okay, is the mean of all this number. So how do we find the mean of all this number? We add all this number, that is 1.54 plus 1.45, 53, and 56 plus 1.44 plus 1.54, and divide it by the number of observations. So what is the number of observation over here? 1, 2, 3, 4, 5 and 6 divided by 6. Doing this calculation, how much do we get is, we get 1.51. So this is our true value or the mean refractive index. Now the second question, second part of the question. The second part in the question is to find the mean absolute error. So second one is to find the mean absolute error, or A del A dash. So to find the mean absolute error, first of all we have to find the absolute error. Then only we can find the mean of that, or you can directly do that. So first of all, let us find the absolute error. So to find the absolute error, what was our true value? The true value which we have calculated on A was 1.51. Remember this, we require it over here to make calculation. So to find the true value for first one, so the formula for finding the absolute error, okay, we are first of all finding the absolute error. Formula for finding the absolute error is true value minus A measured. Okay, there were two conditions. If or either the true value is greater or less than the A measured. So whichever is greater, we'll keep that in first and subtract the smaller one. So for first one, true value is less than the A measured. So we have to subtract this number by this number. So it is 1.54 minus 1.51, which comes out to be 0.03. Okay. For the second one, we can see this is greater. So 1.51 minus 1.45. In the third one, this one is greater than this one. So 1.53 minus 1.51. In the fourth one, this one is greater. So it will be 1.56 minus 1.51. Then the fifth one, this one is smaller. So it will be 1.51 minus 1.44. And in the last one, that is the sixth one, this one is greater, so it will be 1.54 minus 1.51. Now, just subtract it, we will get the values over here. Subtraction. We get 0.06, over here we get 0.02, 0.05, 0.07, and 0.03. So this is the these are the values of absolute error. Okay, remember these are the absolute error. Now we have to do the mean. Mean, first of all, how do you find the mean? The formula was to add all these numbers and divide it by the number of observation. So simply, when you find the mean, what you do is you add all the numbers. You add all the numbers over there to find the mean. You add all the numbers. Okay, all the numbers and divide it by the number of observations. So how many observations are there? It is 6. So how much do we get? Your mean absolute error will be 0.04. Okay. Now the another one. In the question, you also have to find the fractional error. Okay. The third one is to find the fractional error. So fractional error is mean error, mean divided by true value. So your mean is, this is your mean, 0.04. The true value was 1.51. Do the calculation. How much we get is? We get 0.026, or we can write 0.03 by rounding up the number. Okay, this is the third one. Now the fourth one. Fourth one is percentage error. Percentage error. Percentage error is fractional error into 100. Okay, fractional error is 0.03 into 100. This comes out 3%. So the error in the calculation is actually 3%. Now to find it, to write the error in the error limit. I have told you how to write the error limit, that is mean value, true value plus minus mean error. So your fifth is error limit, which is mean value plus minus mean value, it's true value plus minus mean error or mean absolute error. So it is A plus minus del A bar, or you can write this, the answers for this numerical is A is 1.51 plus minus del A bar will be 0.04. This is your fifth answer. Okay. So over here we have studied about errors and how to calculate the errors. This is a very important topic. Please do find different numericals from the same kind of for the same type of numericals and do solve it. If you have any problem regarding these numericals, any topics, please do ask me. Okay. This was for today. We'll continue in the next class. Thank you.